Welcome to this course on programming for financial technologies. Over the coming sessions, we'll explore various programming techniques and tools that are specifically tailored for the financial industry. I'm Dr. S. Ramamurthy, and I'll be guiding you through the concepts and practical skills needed to effectively develop and understand fintech applications. Whether you're new to this field or looking to deepen your knowledge, this course is structured to provide clear, relevant insights and hands-on experience. Let's get started and dive into the exciting world where programming meets finance. This syllabus outlines the course on programming for financial technologies, designed to provide a strong foundation in financial technology concepts and practical programming skills. The course does not require any prerequisites and is offered by the Computing Technologies Department. Its main goals include understanding financial technology fundamentals, working with Python for financial applications, mastering various programming techniques such as linear and nonlinear programming, and using tools like stock option base class for pricing and time series data analysis. The syllabus lists specific learning outcomes, emphasizing knowledge of spreadsheet applications, programming skills, statistical analysis, and the use of machine learning and deep learning methods in finance. The course is divided into 3 units, each allocated 9 hours of instruction. The first unit introduces the evolution of financial technology, financial applications, Python programming, and tools like Jupyter Notebook and Quandl. The second unit covers financial concepts, linearity in finance, pricing models, optimization techniques, and route-finding algorithms using Python libraries like SciPy. The third unit focuses on numerical methods for pricing options, including binomial trees, pricing European options, and writing stock option base classes. Throughout, the course integrates problem-solving, programming, and analytical skills to equip learners for financial technology challenges. This section continues outlining the syllabus, highlighting the integration of stock option base classes and machine learning techniques applied to financial data, including time series analysis and prediction models. It covers various advanced topics such as supervised and unsupervised learning, linear regression, classification, and deep learning with TensorFlow. The syllabus also details learning resources, including key textbooks, and presents an assessment framework based on Bloom's taxonomy with percentages allocated to different cognitive levels across formative, lifelong, and summative evaluations. The design and review of the course are supported by experts from both the industry and technical institutions, ensuring the content is relevant and rigorous. This structure helps us understand how theoretical knowledge and practical skills will be developed and assessed throughout the course. Fintech 1.0 refers to the early phase of integrating technology into financial services, primarily from the 1990s to the 2010s. This period was characterized by the digitization of traditional financial processes rather than the development of new customer-facing platforms. The main focus was on improving back-end infrastructure, which meant enhancing the systems and technologies behind the scenes that support banking operations. Key participants during this phase included traditional banks, regulators, and core banking vendors, who worked together to modernize financial services without significantly changing how customers interacted with them. The legacy banking infrastructure is made up of several key components. Core banking systems, or CBS, are centralized software platforms like Infosys Finacle and TCS BA-NCS that support everyday bank operations. The SWIFT network provides secure messaging necessary for global interbank transactions, ensuring payments and information move safely between institutions. On the customer-facing side, ATM networks and POS systems form the physical infrastructure through which customers interact with the bank's services. However, these legacy systems come with certain challenges, including high maintenance costs, limited real-time processing capabilities, and a monolithic architecture that makes updates and integration more complex. These factors contribute to the growing need for modernization in banking technology. Let's take a closer look at how payment infrastructure has evolved over time. It started with early digital payment mechanisms like RTGS and NEFT in India, as well as Fedwire and ACH in the US. These systems laid the groundwork for electronic transfers but were mostly bank-centric. Then came card networks like Visa, MasterCard, and domestic alternatives such as RuPay, which expanded the options for consumers and merchants to transact electronically. Payment gateways soon emerged as intermediaries, making it easier for businesses to accept online payments through services like BillDesk and CC Avenue. However, despite these developments, there have been challenges with interoperability. Many of these systems operate in silos with limited integrations, which can create friction and inefficiencies across different platforms. Understanding these stages helps us see where improvements are needed to make payments smoother and more connected. At this stage, communication and data infrastructure were key focus areas, with the rise of broadband and mobile data significantly increasing internet penetration. Banks primarily relied on on-premise data centers to manage their infrastructure, which eventually paved the way for a shift towards cloud solutions later on. APIs were still in their early stages, often restricted to internal use or simple point-to-point connections rather than the more open and scalable designs we see today. Security measures centered around hardware firewalls and antivirus software, lacking any zero-trust architecture, which means trust was granted more broadly within networks rather than being continuously verified. This setup reflects the foundational technologies and approaches that shaped early digital infrastructure. The regulatory infrastructure plays a key role in shaping the financial landscape, starting with early compliance technologies used for Know Your Customer and anti-money laundering laws. Licensing is typically restricted to banks, which limits the participation of tech startups in this space. The Basel Accords provide a global standard for banking regulations, helping to maintain consistency across countries. Meanwhile, regulators such as the RBI and SEBI in India, along with the SEC and FDIC in the US, continue to focus primarily on traditional financial institutions rather than newer tech-driven players, which influences how innovation and compliance evolve within the industry. To sum up, Fintech 1.0 was all about building the essential digital infrastructure that laid the groundwork for future innovation. During this phase, the main focus was on creating the back-end systems and technology stacks, rather than on improving the customer experience. This foundational work was crucial because it enabled the development of open banking, APIs, and mobile-first services, which are central to what we now call Fintech 2.0. Next, we'll look at how this evolution has led to the rise of challenger banks and digital wallets, transforming the way people interact with financial services. In the 2010s, we saw a major shift toward digital banking, often referred to as Fintech 2.0. This period was marked by the rise of internet and mobile banking, driven by several key factors. The rapid increase in smartphone usage gave people easy access to banking services anytime, anywhere. At the same time, widespread 4G data networks made mobile internet faster and more reliable. Alongside these technological advances, numerous fintech startups emerged, offering innovative financial services and pushing traditional banks to evolve. As a result, banking transformed significantly, moving away from physical branches and focusing more on digital platforms. Many banks upgraded their core systems to effectively support mobile and web banking, creating more convenient and efficient experiences for their customers. This era set the foundation for how we manage money today.